Assalamu alaikum wa rahmatullah. Good afternoon. Our lab today is Lab 7, which is the lab that comes after Lab 4, because Lab 5 and Lab 6 is nothing. Actually, we don't have exact lab to, lab sheet to follow or something like this, because Lab 5 and Lab 6 are meant to be used for evaluation, for activities, for what they call it, leadership evaluation, for the communication evaluation inside the lab. But because now we are on virtual labs, so we don't have Lab 5 and Lab 6. So Lab 4, we have already taken Lab 4, and now we are going to take Lab 7. Lab 7 is all about Ethernet interface and link configuration. So this one, actually, this lab is all about the link aggregation. So in this lab, we have our learning objectives are as follows. So you will learn how to manually set the line rate on an interface. So you will learn how to manipulate the parameters of the interface, the physical interface. And also you will know how to configure the manual mode for link aggregation, and also how to configure the link aggregation using static LACP mode, which is automatic mode. And also you will learn how to manage the priority of interfaces in static LACP mode. So all of this is to control and to configure, to also to manage the kind or the type of link aggregation. Is it load balancing, or is it bandwidth extension, or it is only to prepare or to configure the application that you need, that the organization require. So based on the scenario, you have to follow the proper steps to implement it. Okay, before we start, actually, I'm going to explain the main concept, which is already explained in the class, but anyway, I'm going to explain again to give the main idea of this. So link aggregation is normally used when we have a bottleneck, for example, like this. If let's say this one is a switch 1 and this is a switch 2, and they are connected like this, and also let's say we have like this. So this is BC1, BC2, and BCN. So for example, if this N is equal to 50, or maybe 100 BCs may be connected through one switch. Actually, the capacity of switches is maximum 84, if I'm not mistaken. Sorry, 48. So for example, only we use this big number, but suppose that is 48 or maybe 32 or 16, 15, 20, something like this. It's already a huge number of BCs that's connected through the same switch. So this switch is connected directly through another switch, which is also connected or connects number of BCs. So let's say this one N and equal to 48, for example. So here we have many BCs in between. Okay, so if this connection, for example, and this connection, also this connection is 1 gigabit per second, 1 gigabit per second. And if this one is also 1 gigabit per second, sorry, gigabit second, like this. So in this case, let me correct this. In this case, so in this case, if let's say we have BC number 1, BC number 2, and BC number 5, for example, wants to transfer data to BC number 1 from here and BC number 2 and BC, for example, number 10 at the same time. So in this case, the total of these links, the total of the traffic coming to switch 1 from the right side to the switch 1 is 3 gigabit per second. And this supposed to be injected or delivered through the one single link, which is only 1 gigabit per second. So here, this BC will get the third of the 1 gig, and this BC will get the third, and the other BC will get the third. So the speed of the network will become very slow. This is the scenario of 3 BCs. So what will happen if we have 20 BCs transmitting data at the same time? So in this case, every BC will have only 1/20 portion of the bottleneck bandwidth. So in this case, we have to understand our application. So we have to understand what is the average of BCs connected at the same time through this bottleneck, So if let's say the average is 5, then if let's say we have enough ports here between at the switch number 1 and the switch number 2, then we can create 5 parallel connections to make it 5 gig. So the bottleneck here will become 5 gigabit per second instead of 1. So in this case, if let's say we have 5 BCs are sending data at the same time to the switch number 2 or to the BCs behind the switch number 2, in this case, every BC will get complete or full 1 gigabit per second. So the speed will be the maximum. But if let's say we have 20 BCs or maybe 10 BCs, then every BC will get half gig. So it's not compared to the previous scenario. So in the previous scenario, if we have only bottleneck of 1 gigabit per second, and we have 10 BCs trying to send data at the same time, so every BC will get 1/10 out of 1 gig. But if we implement 5 concurrent links or 5 aggregated links together, so here, if we have 10 BCs working at the same time, transmitting data to the other side, then every BC will get what? 1/2, which is 5 actually over 10. 5 is the speed of the bottleneck, and the 10 is the number of BCs. So here it will be equal to half gig. So it's not comparable. This one is 0.1 of gig. And this one, after we implement 5 aggregate links, then we will have half gig. As you can see here, the quality of the connection is improved. So this scenario actually is called bandwidth extension, which is only to increase the speed of certain links. Okay, the other scenario, if let's say we have for example, let me take this. If we have, for example, this switch, and this is another switch, and these two switches are connected, it's okay, switch or router is the same thing. Because we have aggregation link at the layer 2, and also we have aggregation link as at layer 3. So it depends on the device that you use. If let's say this is one big building, and this is another big building. For example, this is the ICT site, which is only providing accessibility to internet to all of these PCs here, and also all of these PCs here. So in this case, this is a critical link. Why a critical link? Because this one is not a bottleneck. Because normally the speed of our internet here, if let's say we have 300 meg speed of internet, megabit per second, based on TM, for example, or whatever. So if 300 megabit per second speed of internet, then here we have 1 gig. 1 gig. 1 gig is more than enough to take the traffic of the 300 megabit per second of the internet source. So here we don't have a bottleneck here. We don't have a bottleneck. But this link is very important. Why? Because this link is critical. It's what they call it. It's one of the main connections to connect the network at the right side here. So in case of failure here, what will happen? All of these PCs will be disconnected from the internet. That's why, because this one is very important, we have to implement another backup link here to avoid any failure, okay? So in this case, one link will be active, and the other link will be floating, okay? So floating means backup. So if let's say this one failed, this link will take over and will provide the connectivity. So here in our application, we need to increase the reliability. We need to increase the connectivity. In the first scenario, we only want to increase the bandwidth to avoid the bottleneck. And in that case, all links have to be in the balance mode. So we have to configure them manually. We have to give them the same preferences, same cost, and same everything. All metrics must be equal in order to allow them work in the load balancing mode. But in this case, if we want to make to increase the connectivity or to increase the reliability, then we have to implement the LACP, which is an automatic mode. So in this case, the lowest or the highest priority link will be active, and the lowest priority link will be floating. So in case the active link is failed, then the floating link will take over and will be enabled and will provide the connectivity between the first and second points. So that's all about this. This is the only applications that we have, but scenarios can be different. Scenarios can be inside the data center in itself, or maybe among buildings, or maybe between floors of the same building. So normally, backbone of the building is the main link that links all floors. For example, if let's say we have one building with 5 floors, so in this case, if let's say this is the building, okay, this is the building, 1 floor, 2, 3, 4, 5. So this is 5 floors. So here, normally we put one switch in every floor if it's enough. Otherwise, we have to implement more than one switch. So here, this switch will be used for distribution to the end users. This will be used for the end users. So if let's say here we have 10, here 15, for example, here 20, here 10, maybe here is 40. So in this case, if we want to, for example, if let's say we want to allow them access the internet, for example, so internet normally is installed in one place. So for example, if the internet is connected here, also this have to be connected to the other switches to provide connectivity to the internet. And also, maybe we need to connect these 2 floors, maybe this floor also, the other floor, the other floor. So in this case also, we have to have the connectivity. This main link is called backbone. So this backbone is normally is a bottleneck. Why bottleneck? Because it's connecting a lot of PCs in every floor through single link. So in this case, we have to implement link aggregation here, link aggregation here, and also link aggregation here, link aggregation here, depends on our needs. and also depends on the availability of the ports. Okay, so the link aggregation here will improve many things, will improve the connectivity speed, and also will increase the availability of the network and so on. So this is the famous scenarios that we may face and that may require us to implement the link aggregation. I hope it's clear. So in our lab here, we are going to take a small example like this. So two switches and two links. Okay, let us start with the EMSB. So here we have a new topology. What we want to do is only to go to the switches. We take switch, for example, this one 377 and the other one also 377. Here, let us take the connection here. We take the copper from interface 9. We have to follow the scenario better to avoid mistakes. So it's okay if you want to use like Ethernet 9, Ethernet 20, whatever. It depends on you. It's up to you. Or maybe if you don't want to use this, you can, for example, because this one is Ethernet, maybe we need to use gigabit Ethernet. So in this case, we have to make sure that every command is correct later. Okay. This one also gigabit Ethernet. So here, let us zoom in to make it clear. And okay, we modify the position. Also, we move this captions of the interface names, and that's all. So here we have two links. Okay, let us follow the scenario here. The scenario says here, as the network administrator of an existing enterprise network, it has been requested that the connections between the switches be used more efficiently, or maybe more effectively by preparing the switches to support link aggregation before establishing manual link aggregation, for which the media between the switches are to be configured as member links. So in this case here, to perform basic configuration on the Ethernet switches, auto negotiation is enabled by default on Huawei switches. The rate of 9 and 10 on switch 1 and switch 2 are to be set manually. Why they need to be set manually? Because the rate in both sides must be equal. So we cannot use different interfaces with different speeds or with different parameters in the aggregation, in the link aggregation. So both sides always must be from the same type. And also in every side, every member must be from the same type. Again, I will explain more here because I want to make sure that everything is clear. So here, if let's say we have switch here, and switch here, if let's say we have two links, so this side and this side must be equal. And also this side and this side must be equal. Also this link with this link must be equal. So everything here must be equal to this. We cannot use link aggregation, for example, with different types of links. For example, one Ethernet and one serial. It's impossible. We cannot make it. If we use one link, Ethernet link, so the other members must be also Ethernet links. If we use gigabit Ethernet, all members must be gigabit Ethernet. And if one side the speed is 1 gig, the other side must be 1 gig. If let's say we have one side with supporting 1 gig and the other side supporting 10 gig, then we have to change one side. So maybe we reduce the 10 gig to become 1 gig. Otherwise, there will be no connectivity. So here, let us go and do this scenario. So now I click on this white space, then I click run to start up the devices here. And also after this, I double click on every device to show the CLI. CLI is this black screen, which meant to be command line interface, CLI. Okay, I think it's ready now. So before we start, we have to go to undo what they call it, terminal logging. Okay, this first, and also here undo terminal logging to avoid the annoying messages from appearing. Then we have also to go to system view. If we want to change the system name, then we can make it S1, for example. And this one, for example, system view, system name is 2, if we want to do so. Okay. Okay, here, what interfaces we have used here? We use the interface GE002 and GE001. So GE002 is connected to GE002 and 1 is connected to 1. Okay, so here instead of 9, we will use 2, and instead of the other interface number, which is sorry, instead of 9 we will use 1, and instead of 10 we will use 2. Okay. This command here actually, interface gigabit Ethernet 009, display interface gigabit Ethernet 009, it's going to show you this information, which is the status of the interface and the status of the protocol, which is up here, and the description here, the link type is trunk, negotiated. Why negotiated? Because the automatic mode is already enabled. So you can see here, duplex is full, negotiation is enabled, speed is 1 gig, the mode is auto, and also flow control is disabled. So this is all about the configuration, the automatic configuration. So here we did nothing. We did not configure anything, but anyway, it's by default will be working like this. So if we display gigabit Ethernet, sorry, interface gigabit Ethernet 001 like this. So here we see status is up. Then here we can see the information, and also we can see here last backup, current system, blah blah blah. It's somehow different. Why different? Because we use different switch. So maybe this switch model is not enabled. I mean, the negotiation is not enabled by default. That's why we cannot see the exact information here. So description, we have switch port, we have IP sending frame, then we have the physical downtime, system time, address, last 300 seconds, import, output, and so on. So here we don't have any information about the parameters. And also maybe this one, due to different version of the operation, of the operating system at the switch. That's why it can give us different display results. Anyway, this is not a problem. So what we want to see here, Okay, let us go and follow this. At the switch 1, we check the interface 2. So maybe we use the same command like this, and we use the interface number 2. It shows the same thing, and we don't know either it's working or not working. So as a link aggregation, I mean. Okay, here, if let's say we want to set the rate of the interfaces to become 100 megabit per second, for example, so we can make that, but this is not real or a good practice actually to reduce the speed, unless, for example, you have one side supporting 1 gig and the other side supporting 1000. So in this case, you have to make them compatible. So the 1 gig cannot be 10 gig, but the 10 gig can be 1 gig. So that's why in this case, we need to reduce the speed of the highest link. And normally, if links are the same as in our scenario here, normally we don't reduce the speeds of the links. But anyway, if we want to change the speed of the link, we have to undo negotiation. Undo. Oh, sorry, we have to be in the interface. Interface, gigabit Ethernet, 001. And here, undo negotiation. Undo negotiation, auto. Okay, before this, can we go and check whether it's automatic or not? Okay, now we enable the negotiation. We make it negotiation auto. We want to see if it's still the same, if it shows the same result or not of the display command. Okay. It seems that by default is automatic. So nothing, just forget about what I have done lately in the last command. Let us go back here to the lab sheet and let us follow the things. So here to modify the speed of interfaces manually, we have to go to interface gigabit Ethernet 001, and then we undo negotiation auto. This command will disable the auto negotiation. Okay, so after we disable the auto negotiation, we can manually set the speed. So speed can be set to 100, for example. Okay, so this side is 100. Okay, okay, let us quit and let us go to interface 2 and let us undo negotiation auto, and let us fix the speed to 100. So here we have the 2 ports at the switch number 1 is configured as 100 speed. Okay, so here now we need to go to switch number 2. So switch number 2 is also the same interface, gigabit Ethernet 001. We undo negotiation auto and we quit. Oh, sorry, I have to set the speed first. Speed 100 and quit. We go to the other interface, number 2, and also disable the negotiation and set the speed, then quit. Okay, now the 2 sides are compatible. The speed is 100. The type of the links are gigabit Ethernet, both of sides, and also both interfaces on every switch. Okay, now here, confirm that the rate has been set to 100 megabit per second. So I'm not sure whether it can be displayed, but anyway, let us use this command. So can we find the speed here? I don't see the speed here, I think. So maybe as I mentioned, because the version of the software is different, that's why it shows different results here. We cannot see the what they call it. Cannot show brief. So here, anyway, we are going to configure. I'm sure that everything is fine. The status is up and everything is fine here. So speed must be 100. So the thing that we need to do now is only to configure the link aggregation manually. Why manually? Because we already configured or disabled the auto negotiation. So that's why we have to manually configure the things, the link aggregation. So here, in order to create a link aggregation, we have to create an Ethernet trunk. So to create an Ethernet trunk, we have to write this command interface Ethernet trunk like this. Then we give it a number of the profile. So we can create Ethernet 1, Ethernet 2, Ethernet 3, and so on. Okay, so now our interface for the Ethernet trunk is the trunk, Ethernet trunk 1. Okay, by this command, actually, we created the profile that creates the interface, and it also takes us to the interface view. But because we don't need to do any configuration here, we have to quit. And after this, we have to go to the interface that we want to attach to this Ethernet trunk. So in our case, this is the trunk here. So we need to go to the interface number 1. We attach it to the Ethernet trunk 1. Then we go to interface number 2. We attach it to the Ethernet trunk number 1 to allow them work together. In the manual mode. So here interface 001, then we tell this interface that it is a member of Ethernet trunk 1. So you can see here, this operation may take a few seconds. Please wait for a moment. Done. So here, the interface 001 now is only, now it becomes a member of the Ethernet trunk 1. Okay, let us now go to interface number 2. Then we run the same command, Ethernet trunk 1. So now we have 2 members of the Ethernet trunk 1, which is interface number 1 and interface number 2. Okay? So we quit here. Then we go to the other side. Switch number 2, and we do the same thing. So interface Ethernet trunk space 1. This creates the Ethernet trunk profile for our trunk. So here we quit. Then we go to interface gigabit Ethernet 001, and we say, we tell this interface that UR belongs to the Ethernet trunk 1. Okay, then here we quit. We go to the other interface number 2. Then we run the command of Ethernet trunk 1. Then we quit. So now we manually configured the configuration. Manually configured our Ethernet trunk based on the 2 concurrent links, as you can see in the example. Okay, now let us confirm or verify our Ethernet trunk configuration. So we go on switch number 1 and we use the command, this is the short form of display, Ethernet trunk 1. So here it will show us the members. This is the command. It will show us state information is, work mode is normal, hash arithmetic according to SIP XOR and so on. least active line number is 1. This one means the minimum number of active link numbers is 1. And maximum bandwidth affected link numbers is 8. Then operate states is up, and also number of up port in trunk is 2. Why 2? Because we have 2 members here. So the first member is the interface number 1, and the second member is the interface number 2. Okay, let us go and verify configuration on the switch number 2. Here also we use display Ethernet trunk 1. Is the same thing here, so everything is compatible. Okay, exactly the situation is up, as you can see here in this lab sheet. Okay, this is the manual mode. In this case here, because the 2 links are using the same speed, and also the priority is the same. Why? Because we did not change the default priority, and we did not play with the preferences, we did not play with the metrics and so on. That's why the situation here of the Ethernet trunk is working in the load balancing mode. It's working in the load balancing mode. So this load balancing mode will give us an extension. Now the bottleneck or the link between switch 1 and switch 2 is 200 megabit per second, is the combination of the 2 members. Okay? Okay. What if we want to use what they call it, link aggregation in static LACP mode? So static LACP mode will give us the load. It can work also in the load balancing mode, and it can work based on the what they call it. Actually, the LACP can give us the both ways of the Ethernet trunk, but it depends on our configuration. So here in our example, we use the static LACP mode that only to tell the Ethernet trunk about the configuration of the members, which will be done automatically. So everything will be done automatically. We don't have to undo the negotiation. So negotiation will be automatic, and everything will work as the default configuration. So if the speed is 100, it will stay 100. If the speed is 1 gig, it will stay 1 gig. Okay. So here, as you can see, we already verified the configuration, and the things are working properly. In order to implement the other scenario here, we have to delete everything we have done here on switch number 1 and also on switch number 2. Okay. Okay, let us go to switch number 1, delete the configuration from switch number 1 and switch number 2. So here we have to go to interface gigabit Ethernet 001, and we have to undo the Ethernet trunk. We remove it from the member of the Ethernet trunk. If you can see here, if we display here the Ethernet trunk, you will see only 1 member remains, because we already removed the interface number 1. So let us go to the second interface, and let us undo the Ethernet trunk. So if we quit and we display the trunk, you can see here we don't have any members, and the operate status here is down, while here it was up. So now the trunk is down. Okay, why down? Because it doesn't have any member. Okay, then we go to switch number 2. We go to interface gigabit 001 undo Ethernet, and also we quit. We go to interface number 2. We undo Ethernet. We quit. And here we can display Ethernet trunk is already down. Okay. Now, after we delete the Ethernet configuration from the previous scenario, we still kept the speed configured manually. Why? Because the auto negotiation is already still disabled. Why? Because we did manual configuration. The speed of interface number 1 and interface number 2 are set to 100. Okay, so we still working with the disabled auto negotiation. So our scenario here is only to enable the load balancing mode using the LACP, load balancing mode using the LACP. Okay, let us start. So at first, we have to go to interface Ethernet trunk space 1. Okay. Here, last time in the previous scenario, we didn't configure anything in the Ethernet trunk interface. But now here we have to use the mode LACP. Oh. Yeah, mode LACP. Okay. So now we already told the Ethernet trunk that we want to run, or we want to rely on the what they call it, LACP protocol or LACP mode. Then we finish, we quit. From here, after this, we have to go to interface number 1. Then we assign it to the Ethernet trunk 1. And after that, we quit. We go to interface number 2. We assign it to Ethernet trunk number 1. Then we quit. So here, if we display here the Ethernet trunk 1, you can see here the situation still, the status is still down. Why down? Because we enabled the LACP mode here at the switch number 2, but we did not enable the LACP at the switch number 1. That's why it knows that this switch knows that there are 2 members of the Ethernet trunk, but because the other side doesn't respond, because it doesn't implement or doesn't enable the LACP protocol, that's why you can see here the operation status is still down, and you can see the members here, and unselect 1 gig, unselect 1 gig, and so on. Here everything is available. Here is the partner. The other side is unknown. So this is the local ports on switch number 2, and this is the partner interfaces at the switch number 1. The information here is still unknown. Okay, let us go to the other side, and we go to interface Ethernet trunk 1. Then we enable the mode LACP, quit, interface gigabit 001. Then we assign it to the Ethernet trunk, quit. We go to interface number 2. We assign it to the Ethernet trunk. Sorry, let me delete this. We assign it to the Ethernet trunk. Oh. like this. Then we quit and we display Ethernet trunk 1. So now here you can see, now the status is up. Why up? Because the two sides are using the same configuration, using the same mode, using the same speed, using the same configuration, and so on. So here you can see that the local side at the switch 1 is this ports. So you can see the port 2 and 3, and also weight is 1 and 1. That means load balancing. And the port type is 1 gig, 1 gig. Also here, this is the remote side, the partner of the, the ports at the switch number 2. You can see here the port key is 305, similar to this. And also, I don't know whether there is no extra information here. So here they are using the same port number, port priority, which is 32768, the default value of the priority. Okay, so here the two systems or the two members are enabled, and the now the Ethernet trunk is working in the static mode, which is in the load balancing. Okay. Okay, verify this. We already verified. So as you can see, we got the same results. So set the system priority on switch 1 to be 100 to ensure S1 remain the actor, LACP priority. Okay. So here we have to go to switch number 1, because we want the switch number 1 to be the actor all the time. The actor is going to control the link aggregation. So here we go to switch number 1, we make LACP priority 100. Okay, display now. And we see the things. Okay, system priority is 100 here. It's already modified. But here in the other system, the priority is still the default here, which is 32,768. And let us go here and check if we want to set the priority of the interface also and determine active links on switch 1. So if we use the LACP priority 100 for every interface, then we will see the interfaces are, what they call it, active. Okay, so here we can go to interface number 1. We can use the, what they call it. Oh, we are on the wrong switch. Let us go to switch number 1. So this one has the priority 100. If we use interface number 1, and then we use the LACP priority 100 and quit, then after that we go to interface number 2. Then we assign the priority manually. So in this case, if we quit, let us verify the Ethernet configuration here to see what have been done. So here we should see the priority of the interfaces. It's supposed to be changed. So here, if we display Ethernet trunk, you can see here the priority is 100 and the remote side is 32,000 something. So, okay, let us go here. Let us display now. Okay, the local priority of the local links here on switch 2 are still 300 32,000 something, and for the remote side, which is the actor side, is 100. Okay. So this is how to configure or how to play with the priorities. Okay, the question here, what if we use different priority? What if we use different priority? So if we use different priority, then the smaller the number will be, higher priority will be used for more than the other link. So if, for example, we make this one 75 and this one 25, then it will work like this one is somehow about 75%, and this one will work about will be used about 25% of the link traffic. Okay, so based on the port priority, we are going to control the utilization of the links. Okay, so that's all about the what they call it, the LACP mode, which is the what they call it, the LACP static mode. In here, the two links are working in the load balancing. So if we want to play with the priority, with the speed, we have to disable the auto negotiation. Otherwise, if the auto negotiation is still enabled, then we don't have to play with the priority because everything will be negotiated automatically. So the two parties of the Ethernet link will decide automatically what kind of priority they want to use, what speed they can use, and so on. So this is to display the Ethernet trunk. We have already done this. Now here, if you want to see here, the working mode is static here. Last time, is it static? Last time is here. Okay. Okay, last time working mode is normal, but now working mode is static. Okay, the working mode will be normal if we configure the Ethernet trunk manually. But if we configure based on the static LACP mode, so the working mode will be static. Okay. Where we are, I don't want to skip anything. So here, display this Ethernet and set load balancing mode. Yeah, that's all. Here we finished everything. So if let's say you want to make things clear, if let's say we want to, I deleted everything I configured here in this scenario because I already stopped the devices, because I want to make a fresh configuration for you using the LACP mode based on the auto negotiation. Okay, let me start up things first. Here and here. So based on this here, I will take the lab again, and I will modify some things. I'm not going to use the, what they call it here, the auto negotiation, undo of auto negotiation. I'm not going to do undo. So from here, this command I'm not going to do. The speed also I'm not going to change. The priority I'm not going to change. I will keep everything as the default. So the thing that I want to do is to be in the system view. And before this, I want to undo terminal logging. Then system view. After this, I'm not going to disable the auto negotiation. So I need to create the interface, Ethernet trunk space 1, like this. Okay. Then I'm going to use, if I want to use the manual mode, so I have to quit this. Then I have to go to interface, gigabit Ethernet 001. I have to assign this to the Ethernet trunk 1. Then I quit. I go to the interface number 2 and also assign it to the Ethernet trunk number 1. Then I quit. Okay, this is the manual mode. Also here, we have to undo the terminal logging, then system view. And here we have to create the interface for our Ethernet trunk 1. Then we quit and we go to interface gigabit 1, 001, and we assign it to the Ethernet trunk 1, quit, and we go to the other interface number 2. We assign it to the Ethernet trunk Ethernet trunk 1, then we quit. So, okay, now we configured very quickly based on the manual mode. So if we need to display Ethernet trunk 1. Okay, Ethernet trunk 1 is now active. So the status is up. The working mode is normal, and everything is okay. Okay, now if I want to change this existing manual mode Ethernet trunk to use the LACP mode. So what I am going to do, I have to go to the interface Ethernet trunk 1. Then I use mode LACP, enter. Error. Why error? Because you cannot change the mode of the Ethernet trunk while it's working. While it is working, the status is now up based on the command here. Status is what? Where is the result? Here, the status is still up. Okay, let us check again. Status still up. So to avoid this error, you have to go to every interface members. So you go to interface number 1, you undo the Ethernet trunk. Then interface number 2, undo trunk. So here, if we display Ethernet trunk 1, we will see the situation is down. Okay. Also here we have to go to interface number 1, undo the what they call it, Ethernet only. Then I am not sure whether it can change to, yeah, it can change to other interface directly without quit. So here we undo the Ethernet trunk for interface number 2. Then we can see display Ethernet trunk. Sorry, display Ethernet trunk 1. So the status is down here and down here. So after we disable the manual mode, now we can use the automatic mode. we can use the automatic mode. So how to use the automatic mode? We have to go to interface Ethernet 1, then we have to use mode LACP. Mode LACP, then we quit. We go to interface number 1. We assign it to the Ethernet trunk 1. Then we go to interface number 2. We assign it to Ethernet link, Ethernet trunk number 1. Then we go to the other side. Before we configure the other side, the situation here is still, if we display, the trunk 1 is still down. Why down? Because the other side is not configured yet. So here we have to go to the interface also, Ethernet trunk 1. Then we have to use the mode. LACP static is the same command. LACP or LACP-static is the same command. So here we have to go to interface. Oh. Auto logging is really annoying. So we go to interface number 1. We use Ethernet trunk 1. Then after that, we go to interface number 2. We assign it to Ethernet trunk number 1. Then we can quit. So if we display Ethernet trunk number 1, then here we can see that the situation now is changed. So the status is up. Here everything is based on auto negotiation. So it works fine. So the parameters or properties of the interfaces are not necessary to be changed, like the speed, like the priority. It depends on what scenario you want to implement and depends on the requirements of the organization. So that's all about it. Let us confirm. Also, this side is up. And here we are. You can see all of the information. So what do we have here? Static, blah, 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 number, operation, active port name, this is the partner. Okay, so status is selected, port type is 1 gig, everything is fine. Okay, so here we did not change the weight, we did not change the priority, we did not change the speed. We just enable the manual at the beginning, the manual mode, without disabling the auto negotiation. And after that, we disable the manual mode and we enable the LACP in order to learn both scenarios. So that's all about the today's lab. I have nothing to add. The topic is very simple. So I wish if you can implement it very well. In case you have any question or anything unclear, you can contact me through WhatsApp, throw your questions, and I will answer you as soon as I get time to do so. Inshallah. See you, and hope you get enough time for that. Inshallah. Assalamu alaikum wa rahmatullah.